start with? Just act like you're me.
I started with aluminum.
Okay.
It's not front and it's not oxygen.
Okay.
So since that aluminum has 2, I put a 2 right here.
Okay.
And then after that, I looked at my hydrogens because I didn't want to balance oxygen.
Okay,
again.
now
Or
let me just
sulfur.
slow you down for just a second. You set your aluminum over there. Is there something you could do for safety with that aluminum sulfate over there? It's, yeah, it's understood, but it's so good to go ahead and put it because it tells us he was there, he worked with it, and don't change it again. Okay, Andrew, go on.
Okay. And so then I looked at my hydrogen.
Okay.
So I had 6 here and 2 here, which gave me 8.
Okay. Are you sure you want to go there?
Yeah, but then I saw that I didn't want to really do that yet, so I went ahead with sulfur.
Ah, excellent. Did you see what did you hear what he just said? He tried the hydrogen, and it's not going to work out because his sulfurs were in trouble. Okay, go back.
Yeah. So then I tried to work with my sulfurs. So since this one has 3, put a 3 right here because this is only 1.
Okay.
So I put a 3 here.
Okay.
And so that turned my hydrogen into 6 here, and 6 here, which gave me 12.
Okay.
So in order to do that, I got a 6 here.
Okay.
And then I balanced my oxygens to make sure I got it correctly. So this was 6 plus 12 is 18, and then there is 12 oxygens here and 6 oxygens here.
Perfect. Perfect. Anybody have a question on that? You did a great job. Here, sit this on your desk for the day. Remember, it's a traveling trophy, so I get it back. Okay, everybody comfortable with that? Because what we're doing is we're also doing some reviewing as we go through. So in chapter 3, if you remember, section 1 was about balancing equations. Then the rest of that is all one idea. It's weight problems with a theme and variation. And so we had actually gotten down through section 3, but we're going to head back just to refresh your memory a little bit, and then we'll pick up our last 2 brand new things. Okay, let's balance this one, because there's a little trick in there we're going to have to deal with. Where should we start? What's an idea here? What should we do? Russell, what would you do first? Which one are you going to look at?
I did a carbon first.
Okay, so let's take care of the carbons. Tell me what you want to do for carbons.
What I did at first or what I got at the
No,
end?
what you did at first.
Okay, I balanced them and I put a 2 right there
Okay?
and a 1 right there.
Okay, and he just set the carbons for us. Okay, now, he also set the hydrogens, because all the hydrogens on the left are starting right here. So, Antonio, take a look at that. Come over to here, and what would you like to put in front of the water?
A 3.
A 3, because that gives us 6 hydrogens on the left, it gives us 6 on the right. Okay, now, let's take care of our oxygens. When you look over here on the right-hand side right now, Tran, how many oxygens do you see?
3. I mean, no, I'm just saying that. Okay.
How many total?
7.
7. Okay, so we come over here, and this is the device, and you haven't seen this in class before. You may have, if you're working problems, you may have run into this in some of the practice problems. For the time being, what times 2 is going to give us 7 here? Sarah, what would you do?
I do not know what to do.
Okay, all right, you're in a math class. What times 2 is equal to 7? 3.5, Bruce is saying.
So
Or-
you put 0.5.
You can't just put 0.5, but, I mean, you can put 3.5, right? For the time being, that does, it doesn't mean it's a finished product, because remember, this is trial and error. Okay, so I heard Bruce say 3.5, or if you want to think fractions here, you could say 7 over 2, because 7 over 2 times 2 is 7, right? Or 3.5 times 2 is 7. All right, that's going to lead us to the answer.